Okay, so I have some people telling me they're done. Okay, so let's start going over the questions. For number one, it says how many ways are there to choose 5 of 6 apples? So what this is asking is you have 6 apples and you have to choose 5 of them, and how many ways are there to do that? Um, let's see. Does anyone have any ideas? Want to raise your hand, anyone?
For the first apple, there's 6 choices. The second, there's 5, and so on until you get 6 times 5 times 4 times 3 times 2.
Yeah, but do you need to divide by anything though?
You need to divide uh, by 3.
Yeah, so guys, do you guys understand what Vincent said? He said there are 6 times 5 times 4 times 3 times 2. Oops, 3 times 2. How many do you need to divide by?
I think it's 3.
Okay, so he says you need to divide by 3. Okay, does anyone have a different answer? That was really close, Vincent. Good job. Anyone have any other idea?
Why do you need to divide?
Because here's the thing, okay? Let's say you have apples labeled A, B, C, D, E, and F, okay? So then let's say you picked A, B, C, D, E. Those are the 5 apples that you chose. But picking A, B, C, D, E in that order is the exact same as picking B, C, D, E, A. They're the same 5 apples, right? So we need to divide by the factor that we overcount by. Make sense? So, Anthony, You said the correct answer in the chat. Oh, sorry. Who was speaking?
I just said that I understand.
Oh, okay. So, Anthony, would you like to explain your thought process?
I basically just did like 6 factorial over, can I annotate?
Yeah, sure.
Okay, I'll just like draw what I did, I guess. Yeah, that's
Yeah, so guys, Anthony is using the formula that we learned last time, where you're choosing n items from, sorry, if you're choosing k items from n total items, then you would have n factorial over k factorial. Factorial is when you multiply down. For example, 5 factorial is 5 times 5 times 4 times 3 times 2 times 1. 5 times 4 times 3 times 2 times 1. Did I say that correctly? Yeah. So this is a formula for choosing items. So this is when order doesn't matter. For example, when I said the letters example before, I said A, B, C, D, E is the exact same as saying B, C, D, E, A, right? So here's the reason why. Okay, so Vincent gave us the right start. So we're multiplying 6 times 5 times 4 times 3 times 2. But we do need to divide by the way that we can arrange those 5 items, because that's the factor that we're overcounting by. Does that make sense? For example, if we're given the letters A, B, C, D, E, we can arrange them in 5 factorial ways. We can have A, B, C, D, E. We can have any of A, B, C, D, or E first in the first slot, right? For the second slot, we'll have 4 choices. It will be 5 minus the choice that we picked for the first letter. For the third choice, 2 letters will be used, so we'll have 3 possibilities. So let me draw it out for you guys. You have 5 possibilities for the first slot, then 4, then 3, then 2, then 1. And as we learned, since these are independent of each other, after you pick A, for example, you can still pick any of the other 4 letters. Then that's why we multiply. Okay, so it's 5 times 4 times 3 times 2 times 1, which is 5 factorial. That's the factor that we're overcounting by. Does that make sense? Given any A, B, C, D, E, we can arrange it in 5 factorial ways. We can arrange it in, okay, 5 factorial is too many, but for example, if I had A, B, C, we could arrange this in how many ways? How many ways would we be able to arrange 3 letters, 3 different letters? Any idea? It does have a factorial in it.
12 times 11 times 10.
No, like after you, sorry, I might have worded it wrong, but like once you pick 3 letters, how many ways are there to switch the order of the letters such that you still have the same letters? Like for example, ABC, ACB, BCA, BAC. How many such
6.
sequences are there? Yeah, so it's 3 times 2 times 1, right? So if we picked 3 of the 6 apples, can someone tell me how many ways there would be to choose 3 of 6 apples? And again, choosing 5 out of 6 apples, it's 6 times 5 times 4 times 3 times 2, but we need to divide by the factor that we overcount by. And that factor was 5 factorial, okay? So someone tell me, how many ways are there to choose 3 apples out of 6? Any ideas? How about you, Matthew? Matthew?
Yeah.
Yeah, how many ways are there to choose 3 out of 6 apples? You have 6 apples total. Let's label them with letters. Okay, you have A, B, C, D, E, F, right? And you're picking 3 of the apples. So how many ways are there to choose 3 of those 6 apples?
There are let me think.
Okay, so how many ways are there to okay, so it's going to be 6 times 5 times 4, right? You start with that because for the first apple, you have 6 choices that you can choose. For the second apple, how many choices do you have? 5. And then for the third apple, you have 4 choices. So that gives you 6 times 5 times 4. But what do we need to divide it by? Matthew?
2.
Why 2?
Because
how many ways can you order 3 letters? Like for example, given ABC, how many ways would there be to arrange them? And that's the factor that we're overcounting by. That's the factor of the number of duplicates.
there'll be
Okay, someone else?
okay.
Can you divide by? Samuel.
I think you should divide it by 3 factorial.
Exactly, right? Because once we have 3 letters, there are 3 factorial ways to arrange them. So that's a factor that we need to divide by. Okay, so it's 6 times 5 times 4 over 3 factorial. Okay. Now let's move on to number 2. We spent a lot of time on the first one, but I just wanted to review what a combination was, what choosing stuff was. Okay, so who got number 2? Can someone explain number 2? Aiden, would you like to try number 2? Okay, I think you guys all know how to do number 2. So for the first book, you have 12 choices. For the second, you have 11. And then for the last book, you have 10 choices, right? And this one, since you're arranging them, since the order does count, then there are 1,320 ways to order these books. Make sense to everyone? Did everyone get that? Did anyone not get 1,320? Okay, number 3. How many sequences of flipping 3 coins are there? So for example, I could have heads, heads, heads. I could have heads, tails, heads. I could have tails, tails, heads. Right? How many different sequences are there?
8.
8, exactly. Because it's for each coin flip, we have 2 possibilities. We have heads or tails, right? So we just multiply 2 times 2 times 2 3 times. And lastly, we have someone flips a coin, draws a card, and rolls one die. How many different outcomes are possible? Jerry, do you want to give this a try? Jerry?
So you have so a coin has two sides, so like so you can so there's a multiply by 2,
Exactly.
and then there are 52 cards like in the problem, and then a die has 6 sides, so you just multiply it.
Okay, exactly. Okay, and the final answer is I think 624. So that's the final.
And then you get 624.
Yeah. Okay, good job. Good job, guys. Okay, so good job on the warm-up, everyone. Now, let's take some questions from the homework. So did everyone see the solutions that I posted? Did anyone do the homework? Cool. Okay, so was anyone confused about any of the homework questions? Because I wrote out the solutions, send them to your parents, okay? So if you guys have any questions about that, we can talk about that later. Unless you guys saw the solutions already and are confused about it.
I didn't see the solution.
Okay, yeah, that's totally fine. So how about this? You can see the solutions later today, and if you got any questions wrong, then you can ask me about them on Wednesday. But if you got them all right, then even better. Sounds good? Okay, cool. Any specific questions, anyone? Even if you didn't see the solutions? Okay, no questions? Cool, let's move on then. So today we're going to be learning about algebra. Let me erase this. Algebra is a branch in math where you're using variables to represent numbers. For example, in this class, we're going to be using the variables like x, y, z. Those are the most common ones. You're going to be using A, B, C, D, E, F, the alphabet. Sometimes people also use Greek letters. Sometimes they use symbols, but it doesn't really matter. Those variables just stand for something, okay? So for example, if I say x equals 5, x is a variable, and the number that it's representing is 5. Next slide. So today we're going to be talking about some equations, because the reason why people have algebra is they're using equations in order to find easier solutions to some problems. They can use variables to represent numbers, and then they can find what those variables represent, right? So for example, let's talk about some of the equations that we'll be learning today. So can everyone see these 3 questions? Everyone see that? Okay, so let's try each of them. Okay, so I want everyone to participate. Let's go down the classroom. Let's go around the classroom. Who wants to do the first one? X plus 5 equals 7. I'm sure you guys can all do that. So what I'm asking you, Samuel.
It's 2.
Yes, x is equal to 2, right? Because when you substitute 2 for x, then 2 plus 5 is 7, and it satisfies the solution. Okay, so that's pretty good. Okay, 6x equals 13. And when I don't write any symbol in between, that means multiplication. Anthony?
For that one, you have to do 13 divided by 6.
Yeah, so it's just 13 divided by 6, right? You can also write that as 2.16666, something like that. And then 71 equals 6a minus 1. In this case, you're not finding x, but like I said, variables can be any letter. Daniel.
Turn the 71 into 72 divided by 6 and then add 1, and that's it.
Yeah. Okay. So Daniel uses strategy where you're manipulating both sides of the equation, right?
The answer is 13.
13.
I mean 12.
Yes, exactly. That's good. Okay. So what Daniel did was he added 1 to both sides of the equation. So you see, when two sides are equal, you can do the same stuff to both sides in general, and it'll still be equal. For example, if 5 equals 5, you can add 5 to both sides, and 10 will still equal 10. You can multiply everything by 5. 25 will still equal 25 because the left-hand side equals the right-hand side. So what Daniel did is he added 1 to the right side and to the left side. But remember, what you do to one side of the equation, you also have to do to the other side of the equation. You can't add 1 to one side of the equation and not do anything to the other side. For example, if you have the equation 5 equals 5, you wouldn't be able to add 1 to the right side without adding 1 to the left side, because 5 does not equal 6. And by the way, this symbol, the equal sign with a slash in between, that is the does not equal sign. Makes sense to everyone? So what I think Daniel, what he did was he added 1 to both sides. And this is called isolating variables. So you're putting all the variables on one side, all the numbers on the other side. And when I say numbers, variables are numbers, but when I say numbers, I mean constants. And constants are numbers that are not variables. So they have a fixed value. 72 has a fixed value, okay? Once you do that, you can easily find that A is equal to 12. Next, we're going to be working on some other linear equations. And you might be wondering, what is a linear equation? Okay, so I actually didn't talk about that. Okay, so we'll talk about that in this slide. A linear equation is an equation where the highest power you have is 1. And what I mean by that is, do you guys know what exponents are? If you have 2 to the power of 2, the power of 2 is 2, right? 2 to the power of 2. You can see that little 2 on top, so the power is 2. But if we have x equals 2 squared, this is still a linear equation, because the criteria for being a linear equation means that the variables have to be raised to the power of 1. Does that make sense to everyone? Like, it doesn't matter what the constants are raised to, as long as the variables are raised to the power of 1, then it is still a linear equation. Make sense? So let's go through some examples, and you guys can tell me if it's a linear equation or not, okay? So let's have 6x equals 36. Is this linear or not? Jerry? Or anyone? Is this equation linear? And remember, I said linear. Oh, Mary, is this linear or not?
Yes, it is linear.
Because the highest power is 1, right? And when we don't write anything, it's implied that the power is 1. Something like, let's say, x squared equals 25. Is this linear or not? Mary?
It's not.
Yeah, correct. That's correct, guys. So, like Vincent and Mary said, x squared equals 25 is not a linear equation. Even though it might be easy to solve, right? You can probably find a number squared that equals 25, right? But it's still not linear because the highest power is 2. It also can have fractional powers, but we'll worry about that later. So you guys don't need to worry about that right now. Next, we're going to talk about what a graph is. We're going to talk about how we graph linear equations, okay? So I'm going to throw out some, it might sound like bogus at first, but this is going to be some jargon that you need to know, some part of your vocabulary that you need to know when you learn math, okay? So this is what we call a Cartesian plane, and a Cartesian plane is a two-dimensional plane. It's sort of like a two-dimensional number line, and we use that to represent points, lines, other graphs, okay? Can you guys see the x and the y on the graph? Let me circle it for you guys. So the x on the right-hand side means this is a positive x-axis, okay? So first let's talk about the axes. So you have two axes in Cartesian planes. You have the x-axis, which is a horizontal one, and then you have the y-axis, which is a vertical, okay? If you want to think about it, I think this is something you actually have to memorize, though. It doesn't intuitively make sense at first, but x is on the right, y is up. Okay, x is horizontal, y is vertical, if you want to remember it like that. And x is first, y is last. And that one you can just remember it alphabetically because x comes before y in the alphabet. Okay, so we're going to talk about how do you represent a point on a graph, on a Cartesian plane. So let's look at these points. When you're given a point, the first coordinate is the x-axis, no, sorry, the x-coordinate, and the second coordinate is a y-coordinate, okay? So the x-coordinate tells you how much you're moving right or left. And if you're moving right, that's a positive direction. If you're moving left, that's a negative direction. Make sense to everyone so far? If you have any questions, raise your hand. Or just unmute yourself, ask away, okay? Now, for the y-coordinate, positive means up. It doesn't mean right. Y-coordinate, the positive y-coordinate means up. Negative means down, okay? Because as I said, y corresponds to vertical motion, right? So, again, positive y means you're going up. Negative y means you're going down, okay? So what do the numbers mean? The first number tells you how many you're going to go right or left. The second number tells you how many you're going to go up or down. So for example, if we have the points 5, 3, we'll go right 5, 1, 2, 3, 4, 5. That's our x-axis, okay? Let me write this out so you guys can see it's 5, 3, okay? And then I'll use a different color. Let's use red. Then you have to go 3 up. Remember, x first, y second. And so the point, which I'll draw in yellow, 5, 3 is right here. Can you guys see that? Make sense to everyone?
Yes.
Cool. Okay, so let's take some time plotting some points, okay? So I gave a couple of examples here. Who wants to plot the point 4, 2? Daniel? Okay. Yes, so it'll be, let me try to draw it. It'll be right here. Correct. So you're going 4 right and 2 up. Make sense to everyone? How about -2, -5? Aiden?
So I'll graph this.
Yeah, -2, -5, that point.
So so I can annotate it though, right?
Uh-huh.
So -2, -5 should be about right here.
-2, -5. Okay, so that's a common mistake that some people make. So remember, it's x first, y second. You go negative.
Oh yeah. Right.
And then -5 or 5 down. Okay. And that takes
Oof.
you,
Yeah.
yeah, it's fine. It's fine. Everyone makes these sorts of mistakes. It's fine. So remember, guys, keep in mind x first, y second, and you can remember that alphabetically because x comes before y in the alphabet. Okay, and for our last example, we have -1, -2. Matthew, can you try graphing -1, -2? Just annotate.
Okay. Wait. I don't. Wait. How do I annotate?
Here, I'll give you 2 points. Tell me which one is -1, -2. Okay.
Okay.
I'll do one in red, one in yellow.
It's the red one.
Okay, so you had a 50% chance of getting it right, and you got it wrong. So you're actually going to do the x-coordinate first. You go 1 left, 2 down, -1, -2. -1 comes before -2. Remember, you do the x-coordinate first and the y-coordinate second. Okay, does that make sense to everyone? Okay, so Matthew, I'm not sure if you get it or not. Okay, so let's try graphing -3, -4. Tell me which one it is. Is it this one? The one in yellow? Or the one in purple? Matthew?
The one in purple.
So what coordinate is that?
It's -3, -4.
Okay, what about what are the coordinates of this point?
-2, 1.
Yes, okay, make sure yeah, it's +1, okay? Cool. Does anyone else not get this? Any confusion at all? And if you're wondering why x comes first, why x comes before y, it's just the way it was designed. This is a very man-made type of thing, okay? Or human-made type of thing. So we're gonna be moving on. So a linear equation, the reason why it's called linear is because it looks like a line. So a linear equation is a line that, okay, so it has a slope. Let's talk about what the slope is. Actually, we'll talk about that later. So a line consists of all the points that satisfy the equation. Okay, so the graph of a linear equation is the set of all points that satisfy that equation. Make sense? So for example, if we have y equals 0, right? Remember, y is up or down. So if you're going 0 up or 0 down, then that means all the points on this line satisfy y equals 0. Does that make sense? So it's a horizontal line passing through O. O is what we call the origin. It's 0, 0. You're going 0 right, 0 left, 0 up, 0 down. Make sense? Okay, so Mary, what do you think the graph of x equals 0 would look like?
If x was equal to 0, then it would just be the vertical line passing through the origin.
Yeah, exactly. So x is equal to 0 means you're moving 0 right, no, 0 right, 0 left. Daniel, do you have a question?
If they say does it mean if they say 0, if you need to plot 0, 0, you just plot the very middle of it?
Exactly. So that's what the origin is. Okay, it's the very middle. It's 0, 0. Cool. Now we're going to be talking about how to graph some of these lines. Okay, so to start out by graphing, let's first make a table. Okay, let's make a table, and since you know it's a line, we can connect the points. So for example, I'll do the first one. When you have y equals x minus 2, let's put the x value in, let's put the y value in. This is like a machine. You put in something, it gives you something else. So remember, y equals x minus 2. So let's start at x equals 0. Y would equal 0 minus 2. So when x equals 0, y equals -2. When x equals 1, y equals -1. When x equals 2, y equals, whoops, that is so messy. When x equals 2, y equals 0. X is 3, y is 1, and so on. Okay, so let's plot those points. 0, -2 is here. 1, -1 is here. 2, 0 is here. 3, 1 is here. So if you're looking at these 4 points, you're like, hey, they form exactly a line. You'd be right, because the line passing through them is the equation of the linear equation. Okay, so graphing is really not all that hard once you get the hang of it. This is what the linear equation looks like. And again, it's called linear equation because when you graph it, it looks like a line. So let's have you guys try the other examples. I'm going to erase all these points, but I'm going to still keep the XY table. So who would like to graph the line y equals 2? Jerry? Oh, so is someone raising their hand? Let me check. Daniel?
Forgot to lower it.
Oh yeah, that's fine. Aiden? Mary?
So should I just annotate?
Yeah, you can annotate, I think. Do you know how to annotate?
Yeah.
Okay, cool.
So it looks something like this.
So again, we're graphing the line y equals 2. Yeah, can you, through this table of x and y values, can you show us how you got that?
Okay, yeah. So if we start from the point furthest to the left, which is -4, then we know y will always equal 2. So y has to equal 2. And then since you know no matter what, y will be 2, you just continuously move to the left and right while locking the y value.
Exactly. So like Mary said, x can equal -3, x can equal -2, x can equal -1. And that those are represented by all these points over here. Can you guys see how that works? You have the point -4, 2, -3, 2, -2, 2, -1, 2, 0, 2, so on, okay? So that's how you graph the first equation. Let's move on. Who would like to try graphing the second one? Any ideas? Vincent, do you want to try graphing the second one?
Which one's the second one?
Oh, sorry. The third one I meant. X equals 3.
If x equals, then y is 3.
Yeah, so
And then x can be 1. Well, x can be any number.
oh, sorry. I meant the equation x equals 3.
In x equals 3. Oh. It turns into y equals x. Or wait.
Okay, yeah. So this one is a little tricky because
Turns into y. Or wait.
Here, I'll give you some time to think about it. But in the meantime, I'll try to think of a way to explain it to you guys, okay? So linear equations aren't always 2 variables, okay? Sometimes you even have 3 variables, and that's when you have 3D linear equations. They're still lines, but they're 3D linear equations, okay? These are 2D linear equations. But when you only have 1 variable, it's actually, it's really only like 1 dimension if you think about it. It's when x equals 3, y can be anything, right? So for example, y can equal -1, y can equal 0, y can equal 1, y can equal 2. And those are the points 3, -1, 3, 0, 3, 1, 3, 2. Y can equal anything. And that's why this entire line is x equals 3. Does that make sense to you now? Vincent?
Yeah.
Okay. Do you want to give it another try? Do you want to try y equals 2x?
If y is 4, then x is 2.
Y equals 2x. Okay, so actually, if y is 2, no, my bad. Did you say x is 4, y is 2?
Y is 4, x is 2.
Yeah, so when x equals 2, then y is 2 times 2, which is 4. Right? How about when x is 0?
Then y is 0.
Yes. How about when x is -1?
-2. Or
Okay.
if x is -1, then y is -2.
Yeah, so let's plot these points. So you have 2, 4. 1, 2 we didn't do, but we know it's there. 0, 0. And then we have -1, -2. When you connect all these lines, I didn't draw that too well. So does anyone notice something different about this? Anything weird? Is it tilted? Is it more tilted than the other ones? It's a different angle, right? It's a different slope. Yeah? No? Yes, it is a different slope. Good answer. So let's talk about what a slope is, okay? The slope is, actually, let me go to a different slide for this. Okay, so the slope is the rise over the run. And what I mean by that is how much it goes up given the width of how long it had to increase by that much. For example, let's use this graph. Whoops, I didn't draw that well. So the slope is how much the y value changes over the distance that x changes, okay? And that should make sense to you because when you think of bigger slope, you think of steeper slope. When the slope is infinite, that means you travel some distance up and almost zero distance horizontally. For example, if you have a line that looks like this, you're going up and down, but you're not traveling horizontally, right? That should make sense to you. So in that case, the slope would be it would be infinite, right? But for this graph, the slope is defined as the rise, which is a change in y, over x, which is a change in x. Does that make sense? So who can find the slope for this linear equation? You have the points 2, 3. Let me try to write it neatly. And you have the point 1, 1. Matthew, do you want to try finding the slope for this? Matthew, you there?
Yeah.
Okay, so what's the slope for this equation if it passes through the points 1, 1 and 2, 3? Remember, it's the change in y over the change in x. The change in y values, the change in height over the change horizontally.
It's 2.
Yeah, it's 2. How much does it change horizontally?
1, and it changes 2 in vertically.
Yeah, so it's 2 over 1, which equals 2. Sorry for the messy handwriting, guys. I'm doing this on a mouse because my pen actually broke. So, knowing that, let's learn about a different topic too. Or not a topic, but it's an interesting concept, okay? Another thing that lines have is what's called a y-intercept, okay? And it's called a y-intercept because that's where it intercepts, where the line intercepts the y-axis. Remember, the y-axis is a vertical one, okay? So, when do you guys think that is? If we're given a line y equals 3x plus 2, okay? Do you guys think it intersects the y-axis when x equals 0 or when y equals 0 or both? Jerry? Jerry. Okay, next person. How about Daniel? Do you think the y-intercept, which is when the graph touches the vertical y-axis, okay? That's why it's called a y-intercept. Do you think that's when x equals 0 or when y equals 0? Let's think about it. Oh, sorry. Do you have an answer?
Why?
Okay, so when y equals 0, remember the line y equals 0? It was actually the horizontal line. Y equals 0 is actually the x-axis, okay? So that might seem counterintuitive. Does that make sense, everyone? Vincent, do you think it's what? Okay, so let me tell you guys. It's when x equals 0, okay? And let's have someone try to explain that. Vincent, do you know why when x equals 0, it touches the y-axis?
Because when x is 0, no matter what the number is, it's always going to go vertically down the y-axis.
Exactly. So when x is 0, you'll travel 0 right. Oh, sorry, that was left. 0 right and 0 left, right? It'll just be down the center. So it'll have to be on the y-axis. So let's look at equations in the form y equals mx plus b. Okay? Where m is a variable, b is a variable. They're just letters. They represent stuff. For example, in the equation y equals 3x plus 2, m would be 3, b would be 2. So let's study, where do you think the y-intercept is? And you will actually find that the y-intercept is 0, b. You travel 0 left or right, and you travel b up or down. Does that make sense to everyone? And the reason that is because when you have the line y equals mx plus b, when you plug in 0 for x, no matter what m is, mx will be 0. So y will equal b. When x equals 0, that's when the line touches the y-axis, okay? We already established that. And when x equals 0, mx is equal to 0. So y is just equal to b. So the graph y equals mx plus b touches the y-axis at 0, b. Make sense to everyone? It's a little complicated at first, but b, remember, b is just a variable. Make sense? Okay, let's try one. Let's try to find the y-intercept for 2y equals 4x plus 2. Samuel, what do you think the y-intercept for this graph is? Excuse me. Samuel? Okay, so let's ask someone else. Mary.
Okay, so I think the y-intercept is 1, and there are multiple strategies for this. But I divided both sides of the equation by 2, which gives me y equals 2x plus 1, and b is the y-intercept, so I know it's 1.
Yes, exactly. Okay, so if you got that wrong and said the y-intercept is 2, that's fine because you're just starting out, right? But remember that the coefficient or the number in front of the variable y has to be 1 when we're using that formula, right? Another way to do it is just to rederive it. So again, like I said, the y-intercept is when x is equal to 0. When x equals 0, 4x is equal to 0. 2y equals 2. And what value of y satisfies 2y equals 2? Well, it's just 1. You don't even need a paper to do that. You can just do it in your head. So then this is the y-intercept, okay? And then let's use a slope to graph this. Y equals 2x plus 1. So remember how I said slope is rise over run, right? How much it goes up over how much it goes horizontal. So for every 1 that it goes right, it'll go 2 up. So it must pass through the point 1, 3. And similarly, we'll go 1 right and 2 up again. 1 right, 2 up. And it has to pass through the point 2, 5. And if we go, for example, if we go 2 right, we'll go 4 up. If we go -1 right, if we go 1 left, we have to go 2 down. Does that make sense? So this is scalable. The slope is scalable. Like the slope for a linear equation remains the same throughout the entire graph. And that's why we can say, since it passes through the point 0, 1, it must pass through the point -1, -1. Does that make sense to everyone? So let's use this fact to graph some of these linear equations. Let me see if I have any examples. Whoops, okay, so that is a different slide. Let's try graphing some examples. Okay, so we just talked about the example y equals 2x plus 1. Let's talk about y equals 3x minus 2. Who wants to try graphing this? If no one volunteers, I'll have to call on people. Mary.
Okay, so I can annotate.
Oh, sorry, your audio is a little tiny bit quiet. Could you speak up just a tiny bit?
Okay, so can I annotate?
Yes, yeah.
Okay. So I know that the y-intercept is -2. And then let's say I plug in a number. So if x is 1, that means y equals 3 minus 2. So if x is 1, y also equals 1.
Yes, correct. Because you go 1 right and you have to go 3 up, right? That's exactly right. Exactly. Okay, so Mary is exactly right. From here, you would just extend it out, and that's what the graph of y equals 3x minus 2 looks like. Let's try a couple other examples. Let's try the graph y equals negative 1 over 2x plus 2. Matthew, let's have you try this. So first tell me, what do you think the y-intercept is?
I think it's
Is it when x equals 0 or is it when y equals 0?
it's when x equals 0.
So when x equals 0, what does y equal?
Y equals 2.
Yeah, remember, think of this as one term. Think of it as mx. Okay, so let's start with that. Okay, so would it be here, A or B? What would it be? The one that's on the x-axis or the one that's on the y-axis?
It's on the y-axis.
Yeah, right. Okay, so let's start here. Now, what do we do from here? How do we graph the rest of this line? So so let's think about it like this. Okay, so remember how I said, what does a negative slope mean? Okay, slope is rise over run. It's how much you go up over how much you go horizontal. So in this case, for every 2 that you go horizontally, you go how many up or down?
-1.
-1. So would you go 1 up or 1 down?
You would go 1 down.
Okay, so for every 1 that you go left, how many would you go up or down?
You would go
Remember,
you would go
I said for every 1 that you go left, not for every 2 that you go left. So this one is a little tiny bit different.
would you still go down?
Okay, so a line, if you're traveling right and it goes down, then as you travel left, it should go the opposite direction, right? Because it's a line, it's flat. So let's say you start here, you're traveling towards the right, and you're going down, right? And then you travel towards the left, then you have to be going up, right? So let's first establish that we're going up. Now, let's find how much we're going up by. You're traveling 1 left, how much are you going up by?
2.
You're traveling 1 left. Remember, this is rise over run. So it's how much you go up over how far you go left or right. Does that make sense? So if we're going 2 left, then we go 1 up. So if we're going 1 left, how much are we going up?
Halfway.
Yes, half. Okay, so this is what the line looks like. It passes through -1, 2.5, passes through 2, 1, passes through 4, 0. It also passes through -2, 3, and so on. Okay? Does that make sense to everyone? Everyone got it? Anyone want to give some examples for the rest of the class to do? Okay, so it's 3:58. It's just about time for us to be wrapping up. So if you have any questions, now is the time to ask it.